Okay, so now that we've discussed absolute coordinates, where you absolutely need to know where the origin is in order to identify the points, we're going to talk about our next kind of coordinate. Okay, absolute coordinates are fine, but sometimes they won't work. For example, absolute coordinates are absolutely no help when you don't know where you are. See, if we don't know where the origin is, then we can't figure out what the number line is. We can't see the number line. We can't assign coordinates to the points, right? So if we're not sure where we are, then absolute coordinates are useless. Sometimes absolute coordinates are also awkward, like when we're working with gigantically large numbers. For example, did you know that for civil engineering and surveying, that the state of California, like most of the states west of the Mississippi, use a coordinate system, and that coordinate system is based on a point, and the point is Mount Diablo up by San Francisco. So now, think about how many feet we are to the east of Mount Diablo, and then think of how many feet we are south of Mount Diablo. That's a awful big number to have to type out if we're trying to draw things using coordinates down here in Kern County, right? So if you don't know where you are, absolute coordinates are useless. If we're working with gigantically large numbers and we're just trying to draw small things, absolute coordinates, again, are a pain. Okay, and then finally, absolute coordinates are absolutely no fun when you are working with a sketch or a blueprint that already has dimensions on it. You see, we know how big the lines are, the edges are, we know how tall this is, we know the size, but there's no grid here, right? There's no grid for me to work on. So if I know how large the elements are of the things I'm trying to draw, I don't really want to go back and redraw this on a grid to try to calculate coordinates. So here's another case where absolute coordinates are absolutely infuriating. Okay, so in these three circumstances, when we have no idea where the grid is or no idea where the number line is, when we are working with big numbers, or when we are working off of a sketch or a drawing that already has dimensions on it, we're not going to use absolute coordinates to draw things. We're going to use something called relative coordinates. And what relative coordinates allow you to do is they let you work without having to worry about where the origin is. The format of absolute was x comma y, right? You tell it where the point is in the x direction and then where the point is in the y direction. And that was nice and easy. Well, relative coordinates are going to be a little bit different. So what we're going to do is we're going to assign an absolute coordinate for our first point. But then after that first point, we're going to tell AutoCAD that we're going to describe how much it changes in x. See this little triangle? It's called delta. So we're saying delta x comma delta y. And for AutoCAD to understand we're using these relative coordinates, we're going to put the at sign in front of the coordinate change. So at is the character. If you hold down the shift, it's on the number 2, right? That means go from my last point, and then from that last point, what is the change in x and what is the change in y? Okay, we have an example here to take a look at. We're going to start right here. And to start, well, I mean, you can start anywhere. You can tell AutoCAD start at 0, 0, or start at 1, 1, or start anywhere on the screen. You can actually click with your mouse, right, to start a line. And when you click, even if you don't know where you are, AutoCAD knows where you are, right? So you can say, hey, start right here, click. And then when we type in our relative coordinate, that'll create our geometry. So here, if I just started in the middle of nowhere, and I said at 4, 0, what you're asking AutoCAD to do is forget about the number line. From that point, go 4 to the right, but don't go up or down in the y-axis, right? 4 in the x is the change, but 0 change in the y-axis. All right, and then we're here. So then we're going to get from here to up here. Well, how much change is there from here to here? Well, 1, 2, there is 2 in the x, and 1, 2, 3, 4 in the y. And that creates that sloping line. So we say, hey, AutoCAD, at 2, comma 4, from my last point, give me a new point that is 2 in the x and 4 in the y from where we started. Cool. Now we get to here. Now, this time, if I type in 1, 2, 3, 4 for my change, if I type in at 4, comma 2, something unexpected is going to happen. It's going to go 1, 2, 3, 4, 2. It's going to come out here. Because up to this point, right, positive numbers have moved us to the right, and positive numbers have moved us up. But we're going to the left now. So what we're going to type at this point is at negative 4. Because it's 4 spaces, but it's moving to the left. And then for my change, well, from here to here, the y changes 2. Brings me here. To get from the point at the top to the point at the bottom, how much change? Well, 1, 2 to the left, so at negative 2. 1, 2, 3, 4, 5, 6. Negative 6. Right? Because if I typed in at negative 2, comma 6, well, that would go 6, but it would go up, and we want to go down. All right, so here's our example of relative coordinates. And I hate to say it, but you know, at some point in algebra, they talked about all this stuff, and you thought, when am I ever going to use this, right? So what we want to do is we want to take a look. We want to have a chance to get some hands-on, right? So at page 10.8, there is some description about how relative coordinates work. And relative coordinates are actually easier to work with, I think, than absolute coordinates. Here's the example we were just looking at. And then, hey, remember these figures? These are the exact same figures we were just looking at. We're going to use the same figures over and over as we learn how to use these different systems. Okay, so let's talk about how to set this guy up using relative coordinates.